Hello, long time no see. So I will, do today's coding interview, which is on a binary tree question. Okay, so today's question is this one. So you were given the root of a binary tree. A zigzag path for binary tree is defined as follows. Choose any node in the binary tree and the direction right or left. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. If the current direction is right, move to the right child of the current node. Otherwise, move. Oh, I read it. And okay. And in line 7, it says change the direction from right to left or from left to right. Yeah. So literally, it goes zigzag when going down from root to leaf, and repeats the second and third steps until you can't move in the tree. Okay, so zigzag ranks is defined as the number of nodes visited minus 1. A single node has a rank of 0. So basically, I will count the edges I've I mean, been through. I've gone through. So I will return the longest zigzag path containing the tree. Okay. So, okay. In this question, I will be giving what is the data input? So, yeah, I see. Okay, so let me clarify the interface first. So, in this question, I will be given the root node, and I will return the max zigzag ranks. And I will return, ranks, which is from 0 or larger. Okay. So let me confirm the data input. So root this can be durable. Okay. So if this is root none, obviously I should return 0. And if the given root node is only the node in the tree, it's a binary tree, I should return 0 as well. Okay. Yeah, okay, I see. It's clear for me. So I confirm that the data input root can be null. And so from that, it's clear for me so far. Okay. So let me think of this question with some examples. So I will think of the case. Yeah, some case. Okay, let me think with uh, okay, let me think with this example. So in this example, if I take a look at the possible path, it has, they are 1 to 5, go left and then right, 1 to 5, and also 2, 4, 7, 8, and also 2, 5, and 4, 7, 8, but it already included in 2, 4, 7, 8. Then I'll have 1, 3, 6. And then I will find that 2, 4, 7, 8 is the longest one. So I will return 3. And as I said, I have some other options like 1 to 5 and some others. So one observation I can make from this example is that I can start from basically I can start from any node. Yeah. So I can start from 2 and I can go to 4. Or I can start from 2 and I can start from 5. However, 2 to 5 is already included in 1 to 5, which is who started the parent node of 2. So what I'm thinking currently is that, okay. So if I start from 1 and I decided that I go to right, I can go in that way, in zigzag way, and then find 1 to 5. And also, when I think of 2, I have another way which starts from here, which goes to 2, 4, then 7, 8. Yeah. And then in the same way, when I think of 4, one of the paths comes from 2 and 2, 4, 7, 8. However, I can start to like, okay, in this way. So yeah, in this case, I can go from 4 and go to 4, 0. Yeah. Okay. And when I think of 1, 3 way, I can go 1, 3, 6. However, at 3, I have another way that goes to 3 to say 7. Yeah, which is another way. So I think I can use the recursion. Yeah. And okay. So yeah, let me think of the algorithm from now. So obviously the brute force way is that I will start from any node and then go to from each of them I go to right or left and then go down to the path and until the leaf and count it. Then update the global maximum of the ranks. Yeah. However, I have to traverse, yeah, the same node many, many times in this way. So obviously it knows the, optimal way. So yeah, cyber sync goes some other way. So yeah. So one of the approaches that I use the recursion like this. So I will be given the root node, and then here I will, okay, and also I'd like to clear which way to go. So say when I get the command, when I'm commanded that I should go left. So this happens, say, when this node 3 is called. So like, yeah, think of the case when it is called with 1, and then it would like to go to the, I mean, gets the zigzag range from 3. So it after getting it, this node 1 in this recursion function, it increments the ranks by 1 from the result. Then I get the maximum ranks of zigzag paths from this root 1. So yeah. So for that, it has to command which way it should go. However, from 3, it can also go to 3, 7 way. However, it is, if 3 decide to go to the right, 3 is the beginning of the path. Yeah, because there isn't any parent in the, right hand side of 3. So yeah, that's the thing. So yeah, so I don't know. Start from this node, and this is updates the global variable, which is the max length, which initially starts from 0. So take max length, and also follow go left. This is Boolean direction, and this will return the length. Yeah. Also, obviously, yeah. So it said something happened. Yeah. Okay, so this is the way I can do. So the reason why I have to update max length here is that, yeah, okay, because I will get 1, and I will command that 1 should go to left. Yeah. Okay. Yeah. Yeah. Probably I should update max length even here, even though the parent should be longer. The caller of this root, parent of this root should have longer path, because in the beginning I will call the method with traverse root node, the original root node in the tree, and yeah, in that case, I want the max length to be updated in this recursive function. And then I will traverse this given root. Yeah. And I will return max length. So this is a, yeah, optimized recursive recursion solution. Okay. So I will quickly do the complexity analysis. So for time complexity, I will visit each node only once. So it should be O of n, assuming that n is the number of nodes given in the given tree. And also for space complexity, I need the space for, call stack of the recursion. So yeah, it should be O of n when the tree is like the, you know, one path. Yeah, it just looks like the linked list. In that case, the, call stack is length of the call stack is exactly the number of nodes, which is O of n. Okay, so let me look at the implementation, or maybe I should, start with test code first. But let me define the class No. So with the test, I'd like to do some start from edge cases when B is known. And also if there is only one node, there should be 0 because there's no edge. And then I will think of the case when the tree has, I will think of two cases. When the max ZigZag path starts from root, and also there's a case when the yeah, and also there's cases that when the ZigZag path, doesn't start from root node, so it should be like this. Yeah, so in this case, the max length is 234, which is 2. So it doesn't start from the root node. I will write this test case. Oh, okay, so these are the test cases. So let me start the implementation. So as I said, I will have the global variable max length. And I would define the recursive function. And because it would like to update, they would like to update the max length, this should be the shared variable. So I will define the method here in this, yeah, max ZigZag length method. However, yeah, nested function sometimes is not preferred. So probably I would make this to the class like max ZigZag length finder. and I will share the max strength as the instant variable. But yeah, I will do that later if I have some time, if you prefer it. Yeah, but let me go with this first. So yeah. So first three. If it is, okay, so I see, okay. If this root is none, it should return 0. So this is the base case. Or, but in this question, it's because if root is known, obviously it should return 0. However, think of the caller which calls the traverse method with root known. If the known is returned, it should still return 0 to the caller of that, because the reef node itself makes the rank 0. So wait a minute. So yeah. Okay, so let me think. So wait a minute. So I will think of goal of strength. So when it goes left, if the to the left is none. Okay, so the thing I'm thinking is that, okay, so yeah, the thing is that I'm thinking of this case. So when this is 2, it should return 0. It's okay. But when this is none, this should return 0. Oh, maybe I should return -1. And the caller should add +1 to that, and it will get 0. So okay. Yeah. Okay, so let me go with that. So However, if I do that, the only case I have to take care is that if the given root in the max ZigZag range is known, it should return 0. Because in this case, if this method is called, it should return -1. However, if the root node isn't known, like this, only node 0, so it would call the line 67. And yeah, because this is a known, it should still do the recursion continuously, so it's okay. So that being said, so yeah, then I will return depending on the given goal left. Okay. Yeah. So then here in line 77, I should call the root node with, I should call traverse method with root node. So traverse root, and I should call both of true and false, because for the root node, it can go both of left and right. Yeah. Then I will return max rank. Yeah. Yep. Wait a minute. So let me quickly check in line 67. If go left is true, it should return ranks going left, which is this. So which is it goes to root of left, and it commands root of left that it should go to the go right, because it should go zigzag way. Yeah. So, oh, so sorry. One thing I forgot to do is in root 75, as I said, I have to update max rank with these. Yeah. So this is one thing I have to do. Okay. So let me quickly check with some test cases. So run 101 test cases when known is given. So when root is known in line 58, yeah, in line, okay. In line 55, it should return 0. Okay. So the test case line 102 passes. And the test case line 104, when only one node is given to max length node. So in line, it goes to line 62, and this is 0. And okay, it calls line 84 root true and root false. And when it calls with root true, in line 70, this isn't true. So it goes to line 73, and it calls root dot left and root dot right. Both of them is known. And because, yeah, when the given root is known, it should return negative 1. So both of them become 0. So now I'm thinking of, sorry, so as I said, now firstly I'm thinking of when traverse method is called with node 1 and true in from line 84. Yeah. So basically Max Planck isn't dated. Yeah. So okay. And it should return 0, but it doesn't matter. Yeah. And in line 85, I'm pretty sure that the same thing happens with node 1 and false as the argument. So because root is unknown, it goes to line 73, and both of them, root to the left and root to the right, is none in line 73 and 74. So both of them is 0 and 0. So ranks going left and ranks going right is 0. So Max Planck is still 0. Yeah, and something is returned in line 82, but it doesn't matter. So finally, I will return Max Planck, which is 0 in line 87. Yeah, so this can pass. Okay. So quickly, I will check 1, 2, 3 test case. So when, when this is called with this, so what should happen is, okay, in this test case, I don't walk through the test code, walk through the code one by one, but let me think of just focus on the testing the logic that I've come up. So with this node, okay, the method is called with one true and one false. And this one true calls both of the lengths going left and lengths going right. Result it calls with, oh, oops. So this is 0 and this is this returns because this goes to left. No, wait a minute. So go left is, wait a minute. So, sorry. So 1 is called as true, goes left. Yeah, okay. So basically, to get this, I should call traverse method with, 3 true and 3 false. And when in either way, this is 0. So as shown in line 73, this should be the 1. Yeah. So because ranks left is 1 and ranks right is 0, so in line 59, this should be 2. Yeah. Sorry, no. Yeah. And for this one, line 99, because now traverse none. Oh, so this is 0 plus 1 is 1. So length right is length 1. Wait, this is true. No, sorry. This should return -1. Yeah. So this should be -1 plus 1 is 0. So in rank 59, I will compare ranks left plus 1 and ranks right plus 1. So this should be 2. Yeah. So now I confirm that the test case rank 113 is true. So yeah, it passes. Okay, so I've confirmed those test cases. Actually, I mean, yeah, the last one isn't tested, but I'm pretty sure that now the code works fine. So I will run the run code button. Okay. 159. Oh. Okay, the test passed. So I will run this code in the LeetCode platform. Good. Okay. So yeah, it worked quite smoothly. So yeah, run the code the day today. Okay, thank you. So see you soon. Bye.